Hi, I'm Lackorzynski from Kernkonzept, and I want to give you a small status update on the automotive virtual platform specification we are doing within the GENIVI hypervisor project. So why are we looking into virtualization at all? And the reason is pretty simple, because the automotive industry, and especially IT within automotive industry, is moving from a domain-centric architecture to a central architecture, as seen on the right, where multi-core systems or powerful computing systems play a special and central role, and are there to orchestrate and control and run lots of software controlling sensors and actors in the system. So multi-core system is playing a very important role. And coming to the software running on those systems, how shall the software be orchestrated on the system? And a very natural approach to that is to use virtualization to be able to run independent software modules on the hardware platform, be it new ones, be it old ones, have different kinds of domains which have minimal influence among each other. Other benefits are obviously that you can do parallel development of those software modules or virtual machines, and so maximize your parallelism during development. And also very important, if not the most important things, are that you have clear domains for security and safety, which is obviously a very important topic in the automotive for automotive compute systems. So to summarize this, virtualization is really the key enabler for exploiting performance of today's and future high-performance automotive systems in a safe and secure way. So, and how are we approaching this? Is basically by working on a specification that allows multiple virtual machine or hypervisors to provide a solution here which is interoperable and make virtualization for those that actually use it easily deployable in those automotive environments. And what we want to do is to align the whole automotive community on those common requirements that we are working on, with a specification that is open and can be used and added by everyone. And that one is the automotive virtual platform specification I've already been mentioning. So what is the effect that we want to see from such a standardization? So there are multiple areas where standardization is required for common alignment. That's obviously hypervisor, APIs, how you boot a system, power management, device virtualization, requirements you have at the hypervisor system, and also on architecture. And this gives us some very nice attributes to that. For example, that you can have a virtual machine and can easily port it between hypervisors. You can have common code, which you can reuse among different systems. You can share validation or testing at all and save effort there. You can have obviously multiple hypervisor vendors or virtualization vendors. You can also use that to when you try to lay out a new design, new product, use that kind of specification to describe what you actually want, without the need that you need to do this yourself. And all of that obviously shortens your development cycle. That's also an important characteristic of that. And again, you can reuse your software across multiple projects, multiple projects and implementations. Yeah, and how is that mostly done? So I want to spend this slide on very important aspect of the AVPS we're doing. It's largely based on VHAL. So VHAL, I guess many of you have heard of VHAL. It's a community and industry approved standard for virtual devices. It's very broadly available in common operating systems such as Linux, obviously, and defines an API between the virtual machine and the hypervisor. AVPS selects and specifies modes of the appropriate parts of VHAL, which are used in automotive setups. There is also ongoing work in industry and the community to have more device classes specified in VHAL to bring this even further to support more functionality within virtual machines in a platform independent manner. But AVPS does not only cover, or it's not only basing itself on VHAL, because it also covers other areas, as I already mentioned. So, for example, boot process, power management, and other requirements that are needed within the automotive domain. So, for example, there are some in some areas using dedicated devices and drivers has definite advantages over virtual devices. So, for example, in graphics, it's often the better approach to directly use graphics within virtual machines, and hardware is especially also targeting in that direction to be more virtualization friendly. And the other point I wanted to mention, that there's also other efforts within industry to bring forward standardized virtual platforms, virtual devices. So some of you might have heard of Android Cloud Platform, which is an Android platform or Android BSP for that matter, that is fully based on virtual devices based on VHAL, and allows to run an Android on basically in a device platform agnostic way. Yeah, so a little update on the AVPS status. So version 1 was released some time ago, and we've been working on version 2. In the meantime, version 2 is nearing release and has mainly updates on IOMMU topic, graphics, audio, and some other areas. Yeah, so to conclude, my little update is, so within the AVPS project, we trying to align the automotive community on a common automotive requirements for virtualization, and we're doing that by creating and maintaining an open license specification. We have a call every Monday at 10 a.m. Europe time. If there's any interest to move that time to other time slot, we're open to that. Currently, it's basically defined by the attendees. And we are looking for more contributors, and especially automotive requirements. So to bring more views and more opinions into the specification, so that it allows us to cover everyone in the automotive space, and every requirement and every use case someone might have. So everyone who's active in the automotive area, be it OEMs, suppliers, or operating system and hypervisor guys, you're very welcome to join our activities and yeah, help us build this specification. Yeah, thanks. That's it. Thanks for listening. I'll be available for Q&A.
Hi, my name is Stefan Wysocki. Welcome to Android Automotive SIG Vehicle HAL project. Short update and intro to tech session. So the project is focused to standardize the vehicle data access in context of Android Automotive. Since last all member meeting, we've contributed the POC of external data server architecture concerning the legacy path that is using Android Vehicle HAL to provide the access for third-party applications, but also the modern one that is able to make the apps directly access the data from data server that runs outside Android. Within this, still there is an open topic of access control on server side. We have an open contribution there, but needs to be discussed more and waiting for more contributions even from different parties. From source code management perspective, we've structured our sources a bit to go with the Android state-of-the-art organization using the repo tool and launch configurations. Right now, it should be easier to establish the environment or your PC and be ready for new contributions or evaluating our solutions on your site as well. New platforms are also easy to integrate because we are using this additional layer for the manifest, which is named local manifest. Right now, currently supported device is the Android emulator. We've also evaluated the concept of accessing the vehicle data using the ASP way, but with the focus on translation from VSS format to ASP. This is something that is different to the previously mentioned architecture of external data server, which is focused on exercising different way of querying vehicle data. Here we can see two routes that differs in the API. The one that uses standard Android approach by or using the car service, and the parallel one that might be considered in the future to fill the gaps of limited Android API if we identified any. But right now, the AASIG VHAL evaluates the idea of having all needed VSS signals through standard API. The signals that are already defined by Android shall be translated from VSS. Other that are not defined can be exposed by just duplicating VSS standard name and the format and the unit, and expose it by using something that is called vendor extension in the vehicle HAL of the ASP. We started with the translation between the VSS format and Android. We provided the mapping document between the ASP defined properties and VSS leaves. The mapping contains the relations between the VSS and Android data types, their IDs, unit differences, that sometimes those differences may increase the translation logic, of course, that cannot be auto-generated. But that gives us some knowledge about the differences between the formats, how much they differ, the challenges that we might have, and we might it might provoke some discussions also during the upcoming all member meetings, workshops, or during our weekly meetings that I will tell later. The current implementation is based on the default Android available implementation on the ASP of the vehicle HAL. The translation is done manually. Implemented manually, but at least it should show the concept and be a reference for the script output for the future. We've chosen 4 different properties with different translation complexity. The findings will be shared in a workshop session, I believe. By this, I would like to welcome you to join the session of technical workshops that will focus on a short presentation of the already developed module that translates the properties from VSS format to the Android. It's followed by a discussion about the challenges there, especially if we aiming to make this translation automatic, that is based on specification for both standards, right? The implementation was done on, of course, basing on the previously mentioned XLS sheet. So it was done manually, but we've already identified some places that can be automated. On Friday, though, we have a session together with Vasim about the future of the vehicle HAL and of course the audio HAL as well. To have one joint session together with all the Android automotive interest group to discuss our work plan for the next 6 months. Beside the AAM workshops, the group has the meeting on a weekly basis on 5 p.m. Central Europe time. I welcome everybody and for joining those meetings, and of course looking forward for your input for the next workshops and for our weeklies. So thank you.
Hello, my name is Suhasini Raghuram and I'm a software engineer at Analog Devices. I work with the connectivity group at ADI and I'm here to give you a brief update on the activities of the Audio HAL working group. So who are we and what do we do? As we all know, Android was first designed to be a single operating system, which is in the smartphones. And it's now being deployed in cars, which is rather complex with its own control units, with multiple control units. So our challenge is to benefit from the advances of Android as an operating system and use it in a car as a whole system. So the scope of this working group is audio, which comes with its own set of complex use cases and requirements. So the GENIVI AASIG Audio Hardware Abstraction Layer Working Group looks to investigate the challenges of integrating Android with the complex use cases that exist in car today. The idea is to propose or develop reference designs and implementations for some common problem statements. We have been working on a proof of concept system to integrate external audio mixing systems with Android. The first step here was to extract the raw PCM stream from Android without any effects. We just want to have the pure PCM streams in order to control the audio effects and routing of the whole platform externally. So the figure shows a more detailed architecture. The audio flinger layer is retained as it is since it's already integrated with the Android framework. We look to make changes mainly in the audio HAL layer. We are trying to change the audio HAL to not directly communicate with hardware, but with an external entity like a mixer or an external processor. We are gathering audio data from the audio HAL and passing it to the audio relay component, which is exposing the data to TCP IP socket on the external server. This external server can then easily use the data for streaming or any other purpose. The next step would be to demo this with an external audio system on a real hardware. To that end, we've been working on bringing up the demo on Trout and then integrating it with WebRTC. Using WebRTC as a transport enables a web browser-based UI and working remotely from the Android system. So this could potentially lead to Android system being a hardware in the loop or running on a simulator on a developer platform. In addition to this, we have also been exploring networked audio devices and integrating these in the Android system. We explore two options here. One is the automotive audio bus, and the second one is the audio video bridging. We also presented this in the FOSDEM conference this year. There was some brainstorming on problem of audio synchronization and the available software solutions for it as well. So the next steps for us would be to integrate the demo and show a full audio path on real hardware. We also have exploring options offered by Car Audio Manager and offloading audio to external ECUs as further topics of investigation. Please join us for our tech session on May 7th to know more. Thank you.
Hi, I'm Kevin Valdek. I'm part of the GENIVI Cloud and Connected Services project. In this brief video, I will give you an overview of the project status, and also I will give you a small heads up on what to expect in the workshops that are coming in the next days. So to recap what we have done in the Cloud and Connected Services project, we have been working on an end-to-end vehicle communication framework that starts in the vehicle, how the data is being captured in the vehicle, transferred to an OEM cloud, and how it is then made available to new mobility services or third-party services in general. In the last all-member meeting, we demonstrated this with a proof of concept where we had all these different components up and running. Some highlights of what's going on here is that we're using the VSS, the vehicle signal specification, as the data model. That's one key highlight. As soon as data is being captured in the vehicle, it's done in the VSS format. It is transferred in the VSS format. It's stored in the cloud in the VSS format, and of course, that's also the protocol that is used to make that data available to the third-party services. A second highlight is the W3C VISS protocol that is used to transfer the data from the vehicle edge or from within the vehicle to the OEM cloud. That is also something we are demonstrating in the POC, that we have both a vehicle data server implemented and also a vehicle client in the OEM cloud that connects to the vehicle and fetches the data. So from all these different components, we have done work and implementation. It's available on GitHub. And in the last 5 or 6 months, we've been focusing on the OEM cloud part. So taking POC implementation and trying to figure out how can this best look like in a production environment. And to do that, we have been considering the main kind of platform as a service providers out there on the market, which are Microsoft Azure, IBM Cloud, and Google Cloud. So before, we had different components were running in a containerized format, just running on a server to kind of connect to the vehicle and so on. So we have been looking at what type of services do exist from these different cloud providers that can solve some of the problems that we are tackling. But also we are looking at different approaches, even if we're running a different application or bespoke applications in the cloud, how would that deployment be done? So we are looking at those different strategies as well. Why we have selected these specific cloud providers is more or less because we have seen that the industry, the OEMs, they are using these cloud providers. They are well known. They are already in use. So mapping the communication framework to these services that are provided by these providers has been one of the early choices in this sprint, so to speak, to see how that can work. In the workshops, we will have an introduction to the platform as a service approach in general. So what are the different strategies in using them, and what are the conclusions that we have drawn in the last months. We'll also have different specific studies. So going into AWS, going into IBM Cloud, Google Cloud, we'll look at the different services that exist that solve some of the problems or similar problems that we are tackling in the communication framework, to really figure out what type of services could be used to easily deploy this framework to different cloud providers. And we'll also have some demonstration in showing it. So not only the theoretical part of the studies, so to speak, that we've done, but also some demonstrations on how this can work. We have 2 workshops coming up. First one now on Thursday, where we will have exactly these demonstrations, the introduction to this. There will be definitely room for Q&As and have a discussion as always in these workshops. And a second one on Friday, where we go into the technologies more specifically, do follow-ups from the day before, and also talk about the roadmap for going forward. So hope that you find this interesting and will join us. We'll look really forward to having a discussion with all of you, and hope to see you there. Thank you.
Okay, last project update today is on CVII, which we like to refer to as an initiative rather than a single project. And this is Gunnar speaking. In this brief time today, we can only go over the latest updates and a few particular points. Most of you are hopefully familiar with CVII at this point, but we're always reaching new people, so that might not necessarily be the case. Just be aware that if this seems big and overwhelming, we have plenty of previous in-depth presentations, and you always have the opportunity to reach out for some onboarding before you select which activity you want to be a part of. I want to cover basically the following things with the slides today. So first is to give the message that this is an established ongoing activity. It's been approximately 1 year since we put the CVII name to this. Again, the introduction to goals and concepts will be brief in this session. And for those of you who are familiar, I want to highlight the latest updates and current focus. The initiative is now established, and when GENIVI and W3C started this last year, we essentially put a name to trends and several ongoing projects that were already there. And we found the common intentions on those projects. Among other things, the desire to develop a real foundation for the future vehicle data-driven architecture, including definition of a data model, to continue the need for or the development of shared interfaces. The industry is still looking for that. We want to set technology standards to reduce system complexity and essentially reduce technology and requirements fragmentation in the industry. And CVII is therefore named an initiative for a reason. In order to succeed with the goals, it's really required that projects, interest groups, standard organizations, and consortia in general start talking to each other and find alignment. And so we need that wide collaboration in the industry to meet the goals of the CVII. We'd like to note also that before CVII there wasn't really a concerted effort to achieve this communication, and different parts of the industry maybe had a similar vision but were building conflicted pieces of that vision. Moving into a description of how we have set up 4 tracks to organize the activities. The alignment track is about creating conversations about alignment and avoiding fragmentation. As I mentioned before, we do both high-level outreach where we contact the leadership of the organizations to explain purpose and goals and evaluate interest, and we get into the detailed technical work with engineers from various companies that are interested in achieving these types of alignment and a clear way forward. For the data track, it's about moving to define this common data model together. We are using VSS as a starting proposal, And we're also working on the VSS ontology area, which is derived from VSS. And of course, beyond the model or the how we describe data, we work on the actual specific catalog of data items and move towards a standard catalog there. For services, we are mirroring the data approach, describing what we call a vehicle service catalog, the VSC, with a similar format as the data format. And we're working out a shared method and format to describe all types of services. This is taking into account, of course, existing approaches to this and trying to find a way forward for agreeing on a common way to do it. This, of course, supports service-oriented architecture as well as addressing what is needed in different types of environment in vehicle and the vehicle-to-cloud boundary and for the cloud. The technology stack is something enabled by finding a common model for data and services. It means we can work out and collaborate on the actual software technologies that support these standards and bind these data and services to existing technologies that are needed inside the vehicle as well as outside. Okay, a little overview of how we try to describe the organization of ongoing projects currently. You can see the working tracks as I already mentioned, and then below them various projects and activities. You also see that these are organized by primarily GENIVI or primarily W3C, but we are focusing a lot on the cooperation towards this higher level goal of the CVII. And I hope to see in this picture all of the outreach and discussions we do have already in the alignment track, that some of those may also be stated as named projects or activities. Okay, I promised to highlight the latest updates. We've worked on the alignment track by extending the survey of related standards and technology organizations. I hope you will help us complete that picture if we've missed something. There's a picture I will show to visualize this. We've had in the first contact with new organizations, one working group within the ITU, discussing with a particular individual in the ATA, and of course monitoring the Gaia X project and how also Catena X fits into that whole picture. We've had more discussion with company stakeholders, but certainly would like to get input from those of you who haven't talked about it, about which organizations you're all involved in and what we need to achieve with alignment across those organizations. We had one more discussion with Sensoris on a very technical level that was very useful, I think, to really see what we may build out of that, if there's a possibility to align towards a single data model, or if we should find a way to combine them in a useful way and describe that combination. There are various ways to look at that, and we can make progress. I'm hopeful after having this conversation and better understanding. Various meetings with Digital Twin Consortium and representatives from Microsoft discussing maybe the first concrete example of how to map the VSS ontology to another description language, in this case the DTDL. That's ongoing. Concretely on the VSS projects, there's steady addition and improvement of the standard catalog of signals. For VSC, there's a process for going through the paperwork necessary to get already developed tooling released from a certain company as an open source project, but we also started up joint approaches in parallel this already. The intention is to use the generation tools to really try out technologies in practice before narrowing towards standards or recommendations for the chosen technologies. And of course, linking to known technologies that we know are definitely established in automotive. Okay, let me just show as a quick update the picture we created, including a lot of standards bodies and organizations out there. They're international. They are based in industry general or in automotive or in vehicle technology. And we just, with this picture, want to highlight again the intention of the CVII to of course, add the right technologies to this landscape, but in particular to find this alignment outreach so that we can move towards less fragmentation and get to a point where innovation is possible and things can accelerate. We will speak more about alignment in the upcoming workshop, so I encourage you to join that discussion and add your input. This week you will find a number of different CVII related topics in the agenda that you will find in Swapcard. Recommend you look into that and see which ones you want to join. You will likely see that keynotes are referring to similar and related topics in this week. This is the most important thing for this industry to really work on and get right. The workshops you'll find, we've again had the struggle of wanting to present so many aspects from different companies. So you will find them packed with presentations, but there should be a little bit of time for interactive discussion squeezed in there. And I hope you will use that to be active in the participation. Thank you.